In this tutorial, we'll go through 3 examples on how to calculate the change in enthalpy of the reaction from bond energies. Question 1 reads, hydrogen gas, a potential fuel of the future, can be made by the reaction of methane gas and steam. Take a look. This molecule represents methane, H2O represents the steam, and the products are H2 and CO2. Use the bond energies to calculate delta H for the reaction. The first thing that you want to do is begin by rewriting the reaction using the Lewis structures of the molecules involved. And for these molecules, that's not really hard to do. Let's start with methane. We have the central atom C and the hydrogen surrounding it. So this is what methane would look like, its Lewis structure. H2O, we have oxygen in the central position and 2 hydrogens. Now we do the reactants. The Lewis structure for H2 will be 2 hydrogen atoms held together by a single bond, and the Lewis structure for carbon dioxide is carbon with 2 double bonded oxygens. Just like that. The next step is to find the bond energies between the carbon and hydrogens for this molecule and the oxygen and hydrogen for this molecule. According to our chart, C and H are held together by 413 kilojoules per mole. 413, and since there are 1, 2, 3, 4, we'll multiply this number by 4. For O and H, we have, according to the chart, shown right here, 467. So 467 kilojoules per mole are the bond energies held between O and H. And because we had 2 molecules of water, and this oxygen and this hydrogen, this oxygen and this hydrogen, will multiply this number by 4. So 2 times 2 gives us that. And we'll take the sum of these 2 bond energies. Then we will do the same thing for the reactants, except that the numbers that we find for each of these will be negated. So we'll take the negative of those numbers. In case you're confused, let's look at this. Obviously, there's only 1 bond between these 2 hydrogens. So we look for H and H. That can be found right here. It's 432. So these 2 atoms are held together by 432 kilojoules per mole. And there are 4 of them. So I'll multiply 4 times 432, and we'll negate this. We'll make this negative. We'll do the same thing for carbon dioxide. We have C and O. Looking at our chart, that's 745, except over here it makes a note saying that it's 799 in CO2. So we have 799 times 2. We have 1 here, and that 2 will be negated. We will combine these 2 numbers, and once we find the difference between these 2, we'll combine them with the sum of these. Let's go ahead and do that. Starting up here, we have 4 times 413 plus 4 times 467 minus 4 times, now this number, 432, minus 2 times 799. And you should end up with 194. So 194 kilojoules per mole is the change in enthalpy of this reaction. If you'd like to see the answers to questions 2 and 3, make sure you watch part 2 of this series. We'll see you soon.